Well, good morning, everyone. Welcome to, I guess it's called Engineering Friday these days. We have a very, very, very special guest today, Mr. Bill. Everyone can unmute at this point and clap and wave and
Hey.
all that.
Yeah.
This is great. Bill's actually my father-in-law, but I'm really excited about what he's going to be talking about today. So not to, exemplify his age or anything like that, but he has over 40 years worth of experience, in civil engineering. So this one's going to be a great one. It's got lots of stories, lots of pictures to show. I would encourage everyone to ask lots of questions. It's okay to put those in the chat, and we can stop and even have a little discussion about things. So this is a very fluid thing. So, Bill, thanks for joining us today. I really appreciate it, and I'll pass it over to you.
Okay, well, glad to be with you. Hope everybody is doing well and washing your hands and staying out of mischief. Like Rob said, I've been in the civil engineering business for over 40 years, but I am not going to be able to cover everything in an hour. It's a very, very broad topic, but I think it's an exciting one, at least for me, and so hopefully you can get some of my enthusiasm, and maybe one or two of you would like to join me in the engineering field. So what we'll be talking about is basically what engineers do, civil engineers do, how I became a civil engineer, and that's not necessarily the path for you, but it worked for me. I'll be talking about some of the projects that I work on, and basically, in the end, some recommendations for people who want to get into the engineering field in general, and basically what path to take going into college and high school topics, different courses to take, and so forth. So we can get on to the next slide, I guess. Rob?
Yep.
You're controlling. Okay. Yeah. What do civil engineers do? Well, we're primarily involved in planning, design, the construction management, and maintenance of darn near every physical structure that you see outside. We get involved with building construction, bridges, harbors, pipelines, railways, towers, dams, and many other things. If you drive around and you see some man-made structure out there, it was probably a civil engineer had something to do with that. The road you're on, the pipelines under the street, towers, radio towers and transmission towers, things like that. We work with architects to design buildings. The architect basically fleshes out the building as far as the form and the structure of the building, but the structural engineers, which are that's a specialty of civil engineering, are involved with the framework that holds the building up. And the same thing with bridges and other structures like that. Okay, let's take another look at the next slide, please. You can basically divide the types of construction into two different categories. Vertical construction, which, buildings are an example, and this is a slide, I think, from Kuwait, one of the places in the Middle East, and linear roads, railroads, that sort of thing that go horizontal. So vertical and linear. Let's go into some examples. This is a very unusual bridge, and it's mostly what you would classify as linear construction. The picture itself, it's one of my favorite slides because this picture was from the Library of Congress in Washington, and the picture was taken by Matthew Brady, and he was a Civil War photographer, filmed a lot of scenes, during the Civil War, and he'd get these pictures into newspapers and so forth. But before that, before he was out photographing dead bodies and forts and all of this kind of stuff, he was interested in engineering projects. And one of the projects was the Washington Aqueduct. The aqueduct is it's a series of pipelines that originate way north of Washington. They pick up water from the Potomac River and they run it into the city after it's been filtered. And this bridge is held up by two 48-inch diameter cast iron pipelines. And this whole arrangement was planned by a civil engineer called, his name was Montgomery Meigs. And Colonel Meigs was an engineer in the U.S. Army Corps of Engineers that ran the filtration plant up north of Washington. And he did the design of this pipeline and the bridge. Back in the office, which I can't get to, I've got copies of his original plans. And this was done way before the Civil War. It was done, the actual construction took place in 1858. And the bridge has been reconstructed so that the pipeline doesn't support the bridge anymore, but the pipeline is still there. And I have been up in this pipeline. There's a catwalk that runs underneath the bridge, and right at the center of the arch in the top is cast in the cast iron, Montgomery Meigs, 1858. The man had an ego a mile wide, and he was very proud of his work, and he had the foundry cast his name in that pipeline, and it is still chugging away today after 160 odd years, and it's quite an interesting structure. So anyway, this is a good example of linear construction. The bridge, the pipeline, the roadway on the bridge would kind of typify that kind of work.
So Bill, another way to think of linear might be horizontal.
Yeah, horizontal, linear, as opposed to vertical.
Right.
Yep.
Okay. Very good.
Okay, next one. Back, I guess about, golly, it's going on to 10 years ago, I guess. Mrs. Darrow and I took a trip, a bus trip around the canyons up in the western part of the country, and we took a raft trip down the Colorado River. And this is the Glen Canyon Dam. It was built as part of the the Colorado River feeds water to Los Angeles and a lot of Southern California. A lot of the farms in California water supply is critical because it was basically almost like a desert. And so this dam controls the water supply for all of these places down south. It's also a hydroelectric dam. I've got another view that is not on here of the electric transmission towers that where the generators supply electricity and it's transmitted, all over the place. But this is a vertical construction project, but also you can see some linear stuff there as well.
So Bill, maybe we could, anyone want to sort of take a stab at like identifying a linear and a vertical?
Yeah.
Anyone? Oh, Miles, go for it.
I'm guessing that the aqueduct or whatever it's called across is lineal, and then the dam is up. I forget what that's called.
Vertical.
That's vertical.
Yeah.
Yeah. Very good. The roadway up on top, is that vertical or linear?
That looks vertical to me.
Well, the roadway is going horizontal, right?
Yeah.
And the dam is going up and down. Down in the lower right corner, you can barely see it in the shadow. There's a tunnel.
I see it.
Yeah. And would that be a linear or vertical?
Vertical.
I think it's linear because it goes parallel to the ground, okay? The tunnel is actually an emergency spillway. If the water level gets too high on the dam, they don't want all of the water spilling over the top of the dam. And so they have there's like a valve, a big sluice gate that will release the water and it'll come pouring out of that tunnel. So I imagine if you're in a rubber raft going down the Colorado River like we were, that would give you quite a ride. Okay, on to other stuff. Civil engineering is we consider to be the oldest engineering profession in the world. And examples of how old it might be, although these guys probably didn't go to college to learn the profession, the Romans built things like aqueducts over 2,000 years ago. And the structure over on the left, all of the arches are part of an aqueduct that was built for the city of Rome. And the water actually flowed on top of this aqueduct. They would take water from the mountain lakes and so forth and channel it into these aqueducts, and the aqueducts acted like a pipe that took the water into Rome. You can look at the pyramids, and the pyramids in Egypt were built, basically they were tombs built for the ancient pharaohs, but the construction of these were one of the engineering wonders of the world. They were built by Egyptian engineers over 4,500 years ago. So when you think of that and you think of some of these awesome structures, being involved in engineering especially civil engineering, you can build stuff or design stuff that is going to last a long, long time. And Meigs Bridge and his pipeline and so forth have been around for 160 years. These structures have been around for thousands of years.
Anyone know what the aqueduct system is in on the left there? I've been there.
Yeah.
Yeah, that's the Pont du Gard.
When we traveled to Rome a couple of years ago, the bus driver was telling us about the water system in Rome, and around the time of zero AD, the Roman water system was, the Romans were very good at keeping records, and they computed the amount of water that was in their system back at that time, 2,000 years ago, and the Rome water system was the same. They had the same amount of water in their system as the city of New York did in like about 20 years ago. So it was pretty amazing back then. Wow. What they could do.
That's pretty amazing.
Anyway, you can get involved in all kinds of different complexities of work. On the left side is the Blue Plains wastewater treatment plant in Washington, D.C. And that is the world's largest advanced wastewater treatment plant. It will produce, or it will basically clean the water in the amount of 380 million gallons a day. And that's enough water to completely fill RFK Stadium, where the Redskins used to play. You could completely fill that stadium every day with the amount of wastewater that is processed in this plant. And you look at the, in the background, you see the Potomac River, and it looks like it's brown. Just on the, just beyond the edge of the treatment plant, you can see a pool of dark water, looks black. Well, actually, that water is 99% fresh water. And every springtime, there's a bass tournament, and all of the fishermen like to congregate around the outfall of this treatment plant because the water is so clean, and the bass love to be in clean water so that they can see the bait. So that's where all the fishermen go to fish for the bass. You can get involved in small projects too. You know, if you like gardening and that sort of thing, there are rain gardens that are built on the sides of the road that will filter the rainwater so that it doesn't have to get into the storm drain system. It'll percolate into the ground and feed the groundwater with clean rainwater. So these smaller projects are an example of something that if you like that kind of work, you can get involved in environmental engineering as well.
Plus, it's creating green space, Bill. So
yep.
YSA, we have community garden projects, and
there you go.
We're hoping to give the fruit and vegetables to the homeless community. So then we're sort of building a community and nutrition and things like that. But yeah, they also play a structural role in this urban landscape, right?
Right. Yeah. Yeah. These rain gardens will filter out. Around here we use a lot of salt on the roads when the roads freeze in the winter. to melt the ice, and saltwater intrusion into the groundwater is a real problem. And these gardens are designed to absorb a lot of this, these particles to keep them from getting into the groundwater system. Okay, you can go in some pretty high places. This water tower on the left-hand side of your screen looks like a castle. It was built in the 1930s, and it's part of the City of Washington water supply. And this is built on a hill that is basically the highest point in the city. And I've been up in the top of that cupola, very up on the top of, the part that looks like a pencil at the top, and where the lead would be in a pencil. I've been up in there. That is probably the highest point in Washington. And the view that you can get out of the windows of that cupola are just fantastic. You need to be kind of an acrobat to get up there. There's a ladder that's a little creepy, but once you're up there, it is really beautiful. You can go down as well, and I've been down in this pipeline on the right. It's a 78-inch diameter water main. What the guys are doing in there is that they're repairing leaks in that pipe, and they're doing it with carbon fiber, which is basically what they're making some of the, I think the B-1 bombers are made out of that carbon fiber. It's a material like it's flexible. It's like a blanket, and it gets impregnated with resin, a chemical resin that hardens up like steel. And so they can apply this material to the pipe and coat it with the resin, and it will stick on the insides of the pipe and keep it from leaking, but it'll also reinforce the pipe and keep it from collapsing. And so this pipe is probably 80 years old, and we went inside and we supervised the construction or the repair of this pipe, and so it's good as new now.
Bill, I think Scott has a question.
Yeah, what's up?
So what was the biggest, or like what was your favorite project that you were ever involved with?
I think probably we'll be looking at one of them that was pretty interesting. I've got a couple of examples of what I've been doing, but one involved a radio tower, and the other one involved a pipeline crossing the Potomac River on a bridge, and we'll get to that toward the end. Okay, we've got to take our work very seriously, and back in 1750, about that time BC, so that was, you can do the math, it was about 3,750 years ago. There was a Babylonian king in, I think he was in Assyria, and his name was Hammurabi. And he came up with a bunch of laws to govern his kingdom. And one of the laws had to do with engineering. And what he said was that if a builder builds a house for someone and does not construct it properly, and the house which he built falls in and kills the owner, then the builder shall be put to death. They don't go around killing engineers anymore, but this is just a kind of a reminder that the structures that we build have to be built correctly. Otherwise, they can do a lot of damage and people could get hurt, and there could be tremendous lawsuits and so forth. And so we have to be very careful about what we do. And when we're making calculations on buildings, for example, or for bridges and whatnot, we go over them and over them and over them to make sure that they're right before we let them proceed with the construction. And it's kind of a reminder too, when you're doing your math homework, for example, and you don't just want to, throw it in and get a bad grade. You want to make sure the answers are correct before you turn them in. And that's basically what we're trying to do. But the consequences, if you get a bad grade, it's not going to be very good. But if you make a mistake in the engineering world, somebody could get hurt, and so you have to be very careful. Okay. All right. How did I get involved with civil engineering? What did I do? Why did I want to become one? And this goes back to my dad and my grandfather, and these were all guys that were carpenters. And I am about the first in 5 generations that was not a carpenter. But I was always interested in construction, and I've always been around construction. Back when I was, I guess, probably my first year in college, during my semester break, I helped my dad build a house. And it was in the middle of winter. It was freezing. I was up in the Boston area, and the lumber for the house had come down from Canada, and the lumber was all frozen. And I had to, haul the lumber for my dad and so forth. I didn't do too much of the actual carpentry work, but it made an impression on me. My dad worked very hard to build that house, and it's still standing today. This is a picture from good old Google Street View, and there's a picture of that house there that I worked on. So, it's one of these things that it's part of your family history, and it's something that I was interested in for a long time. Next slide. So the problem was that I didn't really set the world on fire when I was in high school. I was kind of a mediocre student, and I didn't set my goals very high. And I went to a technical college called Wentworth Institute in Boston, and they had a program in civil engineering. It was a civil engineering technician program, and you graduated after 2 years with an associate's degree. And what I intended to do was to transfer, after I finished at Wentworth, into a 4-year college and get my Bachelor of Science degree. So anyway, in high school, I wouldn't call them my favorite subjects, but the ones that contributed most to my engineering degree were math and physics, and surprisingly, English. English is very important because, you know, in my later life, I was having to write reports on what I've been doing in the engineering field, and communication. And you have to be able to tell other people how you want stuff done. And so English is very important, and there aren't too many engineers that are really good in English. And so this is something that if you can do well in writing and communication, you can go a little bit further than some of your competitors. So it's important to have that.
Good,
Okay.
good advice, Bill. Miles has a question.
Yep. Hey, Miles.
While he's asking that, I can tick over to the next slide.
Okay.
He just answered my question. I was going to ask why English is very important.
Yeah. I think, you know, in general life, English is pretty important. Now, communication skills are something that we all need to have. Engineering in particular, but you know, other phases of life as well. I mean, you know, no matter what you do, you need to be able to communicate with others, and so that's why it's important. Anyway, at Wentworth, I got a little ahead of myself, but it was a 2-year technology program. We had calculus and physics. We had drafting. Drafting is making drawings with a pencil and sometimes ink, drawing lines with rulers and straight edges and triangles and stuff like that.
Did you use a slide rule, Bill?
Yeah, well,
you can comment in the chat, anyone that knows what a slide rule is, and that's just limited to our young scientists.
Anybody know what a slide rule is?
They'll need to Google it, Bill.
Yeah. Well, it's do you know what an abacus is? It's an early calculator, and before they had calculators with buttons on them, they had slide rules, and slide rules were they were logarithmic scales that you would slide back and forth, and you could do math on them. Basically, you could do multiplication, division. You could do algebra and some trigonometry, but you know, they didn't require batteries and that sort of thing. But anyway, that was that's old school. Drafting, nowadays, most of the engineering drawings are produced in AutoCAD, and AutoCAD is something that I never picked up. What I did was I did most of my work on pencil, and I would sketch things out, and then we would have a CAD technician who would produce the drawings. This is a skill that would be a good one to pick up as an engineering student. Later on, you might be a little bit too busy to learn it, but if this is something that you could maybe pick up, you know, in the summertime when you're not, I'm not sure how much AutoCAD is taught in high school these days, but if you can pick that up, that might be a good course to add.
Tristan would like to know what AutoCAD is. Yeah, so would I.
AutoCAD. Let me see now. You can design stuff. You can design drawings, and it's a computer aided design is what the CAD is, computer aided design, and you can you can learn how to make drawings by doing AutoCAD. All right, in the summer, my dad got me a job, and he said, well, you want to get into civil engineering? He got me made arrangements for me to work as a summer intern for the town of Sharon, Massachusetts on the highway department. And I'm thinking, boy, I'm going to be a highway designer. I'm going to learn, I can apply all that I've learned at Wentworth in helping the town of Sharon build roads. And so I got assigned to the highway department. And what they did was they gave me a pickup truck and a shovel and a bag of lime. And they said, all right, you're the dead animal patrol. And what I would do would be to drive around town and pick up all of the animals that have been hit during the night, the dead ones, and put them in the back of the truck. And then I drove out to the town had a gravel pit, and I'd bury the animals in the gravel pit. That was not really applied science.
Horrible.
But that was sometimes you have to do stuff that you didn't really plan on, and that was one of the nastier jobs, especially skunks. I hate skunks. I mean, when they get hit by a car, they smell horrible. So anyway, after a while, I guess the supervisor either thought I was doing a good job or maybe not a good job, and he put me on a survey team, and I had learned some of the elements of surveying while I was at Wentworth. So I was a rod and tape man on a survey crew for some time, and you go out in the bushes, and they would give you a machete, and if they're trying to survey some property and measure the property lines and so forth, I'd be the one out in front, and I'd be clearing the brush and getting covered with ticks and that kind of stuff. Then we would take a steel tape and we'd measure from point to point and so forth. That was a little more exciting. Later on, I didn't finish my course of study at Wentworth. I was still kind of in the doldrums as a student. I wasn't really that inspired, and I lost my student deferment. And right about this time, the war in Vietnam was picking up, and they had a draft back then. And what the draft was, unless you were a student or in a special category, you had to register. Well, you had to register for the draft when you became 18, I believe, and you would turn in your information, and they would assign you a draft number. And the draft number every month, I think, when the Army or the armed services needed more soldiers or sailors, they would pull your name out of a hat or pull your number out, and the number would be, based on, I'm not sure how they determined the number, but if your number was called, then you had to report for duty for 2 years in the armed services, unless you had a student deferment. In other words, unless you were in college, or some other, I think there were other categories where, you know, you didn't have to go. But, you know, if you were just working on a regular job, you could be called in to serve 2 years in the Army or Navy or whatever. I decided to enlist, and by enlisting, you sign up for 3 years. I think in the Navy it was 4, and but by signing up, you were guaranteed to have a school that they would train you in, and you could pick from a list of potential occupations what you wanted to do in the Army. And so I picked construction surveyor. And that didn't automatically put me in as a construction surveyor. You had to go to school, there's attend special training. And if you passed that class, then that's what you would do. So rather than being an infantryman with a rifle out in the front lines, I could be an engineer. And so I signed up for a 3-year enlistment in the Army, and I became a construction surveyor. I was in Vietnam for a little over a year, and this guy waving his arms, that's not me, but that is a typical construction surveyor on QL1. This is the main coastal highway in Vietnam, and we were rebuilding that highway. And so that was the road I worked on. Like I say, it's not me, but it was one of my guys. We got, these are some of the vehicles we had in Vietnam. The left-hand side is an M31, what they call the weapons carrier. It's a 3/4 ton truck, 4x4. It had a 100 horsepower engine, and it had a winch on the front. And the winch, you can see it in the front bumper. If you get stuck in the mud, it had a cable on it, and you could wrap the cable around a tree and pull yourself out with the winch. For a time, we also had a machine gun in the back of the truck, and that was the fellow that I replaced when I arrived in Vietnam. He had been riding in a truck like this, and the truck was hit by a B-40 rocket, and it blew the truck up, and he was horribly injured and was sent back to the States. Another fellow who was riding in the truck was shot in the wrist, and he was treated in the local hospital and came back and was working for me on the road. So we had a machine gun that was mounted on the back of the truck, and just for our protection. We never had to fire that machine gun in anger at anyone, so that was good. We were fairly safe from that point on. The road building equipment was, they had an example of that on the right. These are 290 tractor scrapers, and they're huge earth movers that will gobble up 20 cubic yards of earth in one bite and move it somewhere else and dump it. 20 cubic yards is kind of hard to imagine, but it's probably enough dirt to fill a pretty good sized room, like a living room. And so these earth movers were enormous. Anyway, we finished the road. I came home. I served another year in the Army, and then I went out and went to school again. And this time, I was able to get into George Washington University. And since I had credit from Wentworth, I transferred the credit over to George Washington, and I took advanced calculus, physics, hydraulics. Hydraulics is the study of fluids, and water is a fluid, air is a fluid, believe it or not. Different kinds of liquids or fluids. The reason we study them is that we want to know how to design pipelines to carry the fluids, and so that's important for civil engineers. We studied water and sewer design and soil mechanics. Well, soil mechanics, that's dirt, right? How do you think engineers use dirt? Do you have any idea?
Anyone? I might call on someone, Bill. We could call on Jailer, or who else is online here? Scott, Miles, Cyrus, anyone? Oh.
Who would want to analyze dirt?
Miles says gardens.
Well, yeah, but the soil mechanics is more physics than it is biology.
I think everyone's gone quiet.
Yeah. Well, anyway, soil mechanics is it's a specialty in civil engineering. Most structures, what are they built on?
So
what's underneath the structures?
So Tristan, I think.
Yeah.
Tristan has an answer for you.
Okay.
I don't know if he's got the microphone set up.
Oh, okay.
You want me to, I'm just going to say the answer.
I got it.
Yeah. Okay. Hi, Tristan.
Hi.
Why would a civil engineer want to study dirt?
For foundations.
Very good. Excellent. Yeah. Okay. Foundations are what buildings and structures rest on. Okay. And if the soil is too loose, the building is going to settle. It's going to sink into the ground, and we don't want that to happen. So we design foundations to support heavy objects. Sometimes there'll be piles that are driven. Piles are like telephone poles that are driven into the ground with a big hammer. If you've ever had a tent and you set the tent up and you want to keep the tent from blowing away, you pound stakes in the ground. Well, that's kind of like a pile. The further down you drive it into the ground, the steadier it'll get. And so soil mechanics, you study the structure of the earth, and you use that information to tell you how far to drive the pile, for example, or how much load you can put on a concrete foundation before it'll start to sink. So that's why we studied soil mechanics. All right, I got a Bachelor of Science degree from George Washington University. Now, in my case, my dad did not make much money as a carpenter, and so we didn't have a whole lot of money to send me to George Washington University. But one of the good things about being in the Army was that they had a program called the GI Bill, and that is still around, where the armed services will pay for your tuition, at least part of it, but in my case, it was all of my tuition was paid for by the Army. So anyway, I graduated from college, and my first job was with the Department of General Services with the city of Washington. And they put me through some more training. And what they had was what they call a 3-year internship program. And you spent a year in structural design, designing, buildings and that sort of thing. In this case, the Department of General Services was in charge of all of the city-owned buildings and grounds. We had schools, we had police stations, fire stations, all these buildings that were owned by the city. Also Lorton Prison, and Lorton Prison was out in Virginia, but it was owned by the city of Washington. And that was an interesting place to visit. Okay, then we learned project management and contract construction management. So okay, I eventually, after I had gone through all of this training, I took an examination and I became a professional engineer. And a professional engineer is, when you think back to the Code of Hammurabi and, not letting buildings fall and so forth. An engineering license gives you the ability to be in charge of the design yourself. In other words, you're responsible for the work that you do and the work that other people under you do. So this is kind of a management, is a management criteria. You're licensed by the state or the city to do engineering work and be responsible for the work that other people do. And with that, they give you a seal, and this is my wet seal, the thing on the right. You stamp the drawing and you say, all right, everything is here, is designed well, it's okay, and you can send it out for the contractors to build. All right, my projects. I was an inspector on a school job. That school, I learned, has since been closed. So this is like 40 years ago that that school was built. Radio towers, 500-foot radio tower. This is Google Street View, and so the picture is kind of warped. Looks like both radio towers are leaning over, but actually they are straight. Mine is the skinny one on the left. That's 500 feet high, and the contractor that put that radio tower up, they had to fly the top 100 feet or so in with a helicopter. That was quite a show. Anyway, at that time, it was owned by the the inauguration HW, and basically we is on the white. President would sit in the box right on the front, right underneath the presidential seal, and he and his guests, and there would be, maybe 300 guests that would sit in there, would all sit there and view the inauguration parade as it came by. And so that was quite an honor. It was an interesting project. It lasted about 3 months, took about 3 months to put up, and it took about a week to tear it down afterwards. But anyway,
so Bill, I think Scott has a question.
Yeah.
So about the radio tower, the one you did, another thing that they could do, would they be able to use like hydraulic lifts to lift up like what they have and like build it basically from the top to the bottom? By lifting up and putting a layer of metal under it? Well,
it's 500 feet high, so
it would be too heavy.
That would be a tremendous height. I don't think that they would have hydraulic equipment that would go up that high. But
no, like not lifted up, like kind of like a grain bin. How they build like the top level, then they lift it up and build another level under it.
Yeah. I'm not sure that would be the best way to do it, but
Okay.
it's you're thinking outside the box, so that's good.
As a little side note here, Bill, Miles said that his grandpa did the floors for the Oval Office, the President's bedroom, and the West Wing. There you go.
Oh, wow. Well, that was kind of special, and that kind of work was not torn up. This thing, it was kind of sad after the inauguration to see this thing being torn down. But anyway, we got to do it every 4 years. So anyway, I came to the DC Water and Sewer Authority, and I was supervisor of the Civil and Structural Design branch. And like I mentioned before, Blue Plains is the largest advanced wastewater treatment plant in the world. And it has 1,800 miles of sewers connected to it. So we were responsible for the maintenance of the sewers, and I got to wade in wastewater, go in some wastewater pipes with my my waders on, and all kinds of interesting stuff there. But it's interesting. The science of wastewater is fascinating. They have a digester that digests the sludge that is taken out after the wastewater goes by, and they remove the sludge, and it's composted. If your mother has a pressure cooker, basically they have huge pressure cookers that they put this sludge in, and it heats the sludge up to I think it's something like 220 degrees, something like that. And what it does is it kills all of the bacteria and the viruses in this sludge and makes it into fertilizer that farmers can use on their crops. But it also generates methane gas. The methane gas is used to drive steam turbines that provide electricity, and so they have a plant that produces electricity for to running the wastewater treatment plant. So it's it's kind of an interesting renewable resource. On the clean water side, when I came to Mont McDonald, we are in charge of the city's drinking water system. Ryan Street pumping station, which is a huge pumping station, which is like the heart of the water system, literally the heart, because it's connected to all of the water pipes in the city. And so the pumping station pumps water to all of the residences and the buildings around in the city. Tank number 2 is a 1 million gallon water tank. Sometimes we have to go in there and inspect it every 3 years. And sometimes when they can't take the tank out of service, you can go up inside the tank. There's a ladder that goes through and you can go in a hatch inside. Sometimes they can't take the tank out of service, and so what they do is they launch a small submarine. And the submarine swims around in the drinking water supply, and you can get videos of the condition of the tank inside.
Bill, a question. The red and the blue round cylinder things there. What's
Yep.
the big difference there?
Okay, those are big electric pumps, and the city has what they call different pressure zones, and if you live at the top of a hill and the pumping station is down on the bottom of the hill, you have to pump the water up in order to get enough water pressure at the top of the hill. If the buildings are down at the bottom of the hill and the pumping station is up near the top, you could put enough pressure in the pipe to burst the pipe. There's too much water pressure at the bottom of the hill, not enough water pressure at the top of the hill. And so they divide the pressure up into different stages so that you're not breaking pipes all over the city. So the red is first high service, the blue is low service, and so on. They have different color codes for the pipe. Okay, lost the slide.
Yeah, I just wanted to, I'm not sure how many slides are left, Bill, but I wanted to give an opportunity to see if anyone had any questions.
Oh, yeah.
I think Cyrus might have a question here. I knew he'd ask this question. Cyrus, do you want to have a go?
Hello, Cyrus.
I'll ask for you. Do you work with filtering out PFAS and chemicals that are in the water?
The water filtration plant, it's kind of interesting in Washington. The water filtration plant, which Montgomery Meigs built back in the 1800s, that's run by the Corps of Engineers, and they have a filter plant way up in Dale Carlia, which is north part of the city. They take the water out of the Potomac River, and they run it through filter beds to filter out the impurities in the water. As far as chemicals are concerned, there is a chemical process that they use to take these hazardous chemicals out of the drinking water supply, and so that's how they work it. Back one slide, Rob.
Well, actually, you want to go one slide?
No, one more.
Oh, I'm just, it's coming towards over an hour. So
Yeah.
would it be okay if we just did this last one?
Yeah, okay. Yeah, one of the interesting projects that we worked on was on Key Bridge. There was a pipeline that went across Key Bridge, and it supplied water, well, it still does, to the Pentagon. Pentagon is the largest office building in the world. And during the terrorist attack during 9/11, there was an airplane, the terrorists flew an airplane into the Pentagon to try to kill a whole bunch of people. Well, they did. But it caused a tremendous fire. And the huge amount of water was necessary to put the fire out. This surge of water created a huge force in the pipeline on the Key Bridge. We had to inspect that pipe, and we found that it had done some damage to an anchor for that pipe. And so we were able to, number one, we were able to determine that it was caused by this terrorist attack by running a hydraulic model, and we were able to repair the damage with carbon fiber wrap, similar to the carbon fiber wrap that was used to repair that other pipe that we were walking inside. And so this was an interesting application. We were doing it from a cherry picker, a bucket truck that was 70 feet above the river. The equipment was mounted on a barge that was pushed by a tugboat. They drove the tugboat in underneath the bridge, and we jumped in the bucket truck and went up 70 feet to inspect that pipe. So that was kind of exciting. So anyway, getting on to final thoughts, and I can't see the right side of the slide, but basically what I'm saying is that each of you guys has a gift. You learn stuff, and the most valuable lesson that I learned in my experience has not been from all of the education that I've gotten, but from other people. And we talked about communication earlier, and English and so forth. The best way, the most important lesson that I learned was to share information with other people, because it allows them to learn, and you learn as much as what you give to other people. So share your thoughts with other people, talk to each other, and most importantly, listen to what other people have to say. Yeah. And that's it.
That's so true. Some great advice there. I think Tristan has a question, actually.
Yeah.
I don't have a question. That was my mom.
That was me.
Oh.
Sorry. I get asked this a lot, and I think other people might be curious, but what's a typical day like for you? Is it always climbing in pipes?
No. I would say probably 95% of my work is done in an office setting. The most exciting parts, obviously, are the ones where you go out and you see what you've built, or you see what is going on. But a lot of it is basic office work, computer skills, which mine are kind of off and on. But design work. I attend meetings. Part of a lot of what we do now is planning for new construction. And so it's basically office work now.
So I have like a quote that's about sharing knowledge and stuff, and it's like that knowledge not shared remains unknown.
That is very, very true. And you don't want to lock up your knowledge. And sometimes, you know, something that somebody else doesn't, and that's kind of cool. But you don't you get a lot of satisfaction about seeing other people grow, and I like helping out the young engineers in my office to learn some stuff, and I learn as much from them as I'm still learning every day about things, and you know, the sharing of knowledge is a wonderful thing.
And then I think Miles, your brother, wants to say something or has a question.
Yeah.
That was very interesting.
I didn't get that.
He said it was very interesting.
That was very interesting.
Oh, it was very interesting. Oh, thank you. It's been a lot of fun, and you know, 40 odd years have gone by in an instant, it seems. So it's been a lot of fun for me. That's why I still do it.
I have one final question. So we have a lot of girls that are really getting interested in engineering and science and, you know, math, physics, a lot of the things that you've been talking about. Do you have any advice for a girl or a early career woman getting into engineering, and advice that?
Well, my present boss is she's basically a chemical engineer. She's probably I don't think she's even 40 yet, but she has a lot of drive. She is very, very assertive. She's very, very competent, and she has a good, you know, highly intelligent. But what she's been doing is she's been relying on me for the technical part of it, and this is all part of the sharing process. You know, but I think in general, civil engineering, when it started out, women were very rare in civil engineering. But we have probably, I would say 25% or maybe 30% of our people working for Mott MacDonald worldwide are women, and they are doing very well. The pay scale, I don't see the glass ceiling in civil engineering. In other words, paying men more than women for what they do, and you know, our engineering office, and I think our field is very very good at promoting women and so forth. I know a couple of women who are actually owners of engineering companies, and they've done very well.
Very good. Actually, there's one more question here. It's either from Beth or Tristan. Is civil engineering a stable career?
Well, for me, it has been. In 40 years, I retired for 3 weeks, and then I came back. And that's the only gap in my employment in my entire career. So I would say for me, it's very stable. The infrastructure repair, the infrastructure replacement in this country is a huge huge job. You know, I think that I'm not sure that civil engineering gets the recognition that it should, but there's certainly plenty of work to be done.
True. Well, thanks again, Bill. And then for today, really appreciated everything. That was a really inspiring talk. And I think Scott wants to.
Yeah. Thank you so much for like all you've done for our country's infrastructure. Like probably without you, like the Pentagon, it wouldn't be the same. For example, with all that stuff you did with the water.
Yeah. Well, it's you know, we try to do everything we can, but you know, the problem is that the repair is very expensive. You know,
Right.
Nowadays, you know, if you have to fix something buried in the street, you have to dig up the street, and now they're finding ways that they can use robotics to do a lot of repair now. A lot of the sewer repair and some of the water main repairs are being done by robots that are loaded into the pipes, and they go in there and they repair the inside.
I had.
Okay.
Yep. So yeah, that's the way things are going, and you know, a lot of you guys that are interested in robotics, you probably might want to take a look at some of these projects that involve what they call no-dig engineering, where they go in and do repairs robotically inside pipes and stuff.
Yeah. That's cool stuff, Bill. Well, again, thank you for your time today and sharing all your words of wisdom. And
Thank you.
yes,
Yeah,
and
you're
so
welcome.
everyone can now unmute their microphones and give one big thank you and a round of applause to Mr. Bill. That was
Yeah,
awesome stuff.
thank you.
Really, really great stuff. And stay safe, stay healthy, everyone, and enjoy the beautiful weather this weekend.
Thank you,
Yeah.
Rob. Take care.
All right.